All right, in our last video, we wrote our very first parsing function where we were parsing out the method of the HTTP request. We also saw how we can test it using this equality assertion here in Rust. And, when we broke it, it broke. When we wrote the correct assertion, it passed, which is what we should expect. Um, this is nice. It means we have this little reusable piece. We can also do another check. So let's add a comment here. We're going to say um, checking for get parsing. We should expect that if we pass in a different, here, let's copy this, save ourselves a little bit of copy paste. Checking for post parsing. And we want to pass in post test form URL encoded. Cool. We should be comparing that against a post. And again, just to check. All right, cool. We didn't crash, or at least it didn't panic. And our code is working, at least up to this point, the way that we expect it. We, as a part of our testing, we should also give it sort of a garbage input as well. So maybe let's do that right now. So we're going to check for unsupported. Let's do byte string, just directly in here. Some garbage, blah, yeah. Okay. And unsupported. All right, cool. All of our assertions are passing. We're in a good spot. I think the next thing that we want to write is parsing out the version here. This is going to be a little bit tricky. I will see if I can do it on the first pass. If it looks like I'm getting stuck, I'll probably pause the recording for you, go figure it out, and then copy it back in and explain what happened along the way. All right. So we know. Let's look at this overall structure. Um, all these pieces, again, the very first line is always separated by space, this space character. If we want to zoom all the way in, close it, get out of the way. Whoop. Get. All right, so we have get, we have the URI, space, version, space, and then our new line character. Well, we'll get there. You know what? No, I think now is actually the time to talk about that. So let's put this back semi-normal size again. What we don't see, and this is one of the reasons that parsing strings is somewhat perilous, is that as a part of this protocol, the new line is not just it's not just a backslash in character. Instead, what we have is a carriage return and then a new line. So the combination of these two bytes are what actually delineate one line from another in terms of this protocol. So we need to restructure our test strings to make sure that we don't have any unexpected parsing issues. So what we see here between this line and this invisible new line character there, that varies from operating system to operating system. For the sake of making sure that what we're doing is able to be consistently tested, we should specify it here. So we're going to replace all these new lines. Well, I'm going to do this. We're going to replace all these new lines with these characters, which is a terrible experience, I understand. But also, okay, so yeah, but I'm not necessarily doing this for your experience. I'm doing this for your knowledge. People who say you shouldn't have, If we wanted to make this look pretty, I could enable, line wrapping, but I'm not going to do that right now. Okay, again, we're going to do same thing. Okay, good, and cool. So now the structure of these bytes should look like it would look if we were reading it off the wire. And that's going to come into being very important here because we need to be able to see, we need to be able to find out where the lines are inside of our request. So let's make sure we're doing that. Okay, cool. So let's talk through the process of what is required in order to pull out this substring here from this stream of bytes. Number one, we need to actually figure out where's the end of this first line. That's why we just went through the exercise of adding in these proper carriage return new line characters into our stream of bytes that we got. So number one, we're separating our lines. Number two, we need to separate things out based on this space character. Okay, cool. So lines, spaces, and then once we've done that, we need to enumerate and see, do we actually, like, okay, I have an unspoken assumption here. When we split this, we, in general, are expecting there to be 3 pieces. But what if we only have 2? If we only have 2, then what that means is that we're either interacting with a non-compliant client application, or it's 0.9. If we have a non-compliant client, we're just going to assume that they're talking to us in 0.9. So this is, and if they're really not 0.9 and we use the wrong thing with them, well, that's their fault. Part of protocols is that you can only support what you're doing, and you can't worry about necessarily what others are doing. The whole purpose of the protocol is that everybody follows the same rules, and that you don't have these issues that pop up. In theory, most of the time. All right, so we got that. Now, what we're going to be doing is, let's say, let HTTP version, and just like we were doing before, we're sort of predefining the contract that we want this function to fulfill. We're going to give it the buffer again. So we're going to say, for the fun of it, we're going to say OP, pass in get test plane. Again, let's say HTTP version. All right, and we're gonna let it go ahead and generate that signature for us. It again tried to look at the exact length. We don't care. We don't necessarily want to do that. So it doesn't like that. I'm sorry. Okay, fine. My apologies, dear compiler. When you hear people talk about fighting the compiler in Rust, I tend to think of it as a rather strict teacher that's there constantly slapping your hand as you're doing things wrong. And then what happens over time is that you modify your behavior so that your hand stops getting slapped. It's all right. It's all part of the type safety, the boundary checks, the lifetimes, and ownership. And if you don't know what that means, that's okay. You can go Google that. For right now, we're going to focus on parsing out the version from the request. All right. So this to-do thing here is just so that the compiler will stop yelling at us that we're not returning this yet. Okay, so the first thing that we want to do is split on lines. After we do that, we want to take the 0th result of it. We should have, at the very least, we should have one line. At the very least. If we don't, then something's wrong. If we have a sequence of bytes where we don't have at least the carriage return, new line uh, bytes, that means we have not received a full request. We haven't received even the minimum amount of a request yet. And if we run into that, well, we're not going to handle that right now. We're going to assume that what we get is correct, and we're going to kick that can down the road. The way that we would handle it is that the framework, whatever larger framework is calling into this HTTP module, we're going to have to send it some type of signal saying, it's not all here yet. Go do something else and come back to us when you get more data. But for right now, we're not going to handle that. Yeah, we live in a perfect world at the moment. Let's throw with result. All right, so this is meaning which is the first line of the request header. All right, the next thing that we're going to be doing is split on the character. So we're splitting on the space character. Then we're going to do a check, as we talked about. If we only have two pieces, then we're going to assume version 0.9. Check if we have two pieces. And we could do two. We could do checking, greater than or equal to two, whatever. No. We're going to simplify it. We're just going to make sure if we have two, we're gonna assume that it's 0.9. Think of some ways where that can backfire. I can think of several. For example, what if somebody forgets the URI and just sends us a method and a version? In any case, we're probably going to send them a 404 because we're not going to be able to find the page that's called http:// blah, 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 blah. So, all that being said, we're gonna make this assumption here. All right, so check if we have two string segments. Returning v09 if true. Otherwise, we're going to do our match, our comparison, similar to what we were doing with our method parsing. Match against third element and assign an enum. Cool, we have the structure. And now let's start trying to write the code. I try to keep these videos under 20-ish minutes, so let's see if we can do this in the next 6.5 minutes. Okay, so number one is we have this buffer. Let lines equal get, you know what, I don't like that, we're going to call this buffer. Yeah, buffer dot split. I know there's a split method. And that's fine. We don't necessarily care about how many predicate, doesn't match the predicate. Okay, so we're literally going to do, is this wanting a string or is this wanting a, okay, slice. All right, that's fine. We're going to give it, see if it will take this. Yeah, it doesn't like that. It wants only one. There shouldn't be anything, if somebody's sending us a proper request, there shouldn't be any reason somebody is sending a premature carriage return character. So this should be okay. So I'm going to do \R. If this breaks, again, we're kind of in not our fault territory. Um, so split, that's fine. Implemented for character. Ah, come on. All right, fine. You're gonna make us do something different. Let's take a certain amount of our slice, a certain amount of our buffer, and convert that into a string. It's not my favorite way to do it, and we'll probably come back and make it more efficient. Um, but let's go ahead and do it. So let's do inner string. So we're going to do from UTF-8, and this is when we have vector. So we're going to do buffer. We're going to assume that for our service, and maybe this is wrong, this is why I don't necessarily like what I'm about to do. We're going to assume that the initial line of the request coming in is less than 1,024 characters. That is less than a kilobyte. Maybe that's wrong. Maybe there'd be some super long URI that would go beyond that. At the moment, for getting this done, we're going to make the assumption that that is not the case. So we're going to say 1024. So we're going to try to take a slice of this buffer, the first 1024 bytes of it, and we're going to say as vec or to vec. Yeah. So instead of, okay, so we're allocating a vector around that slice and then passing it into this string. And we're going to assume that that all works. Again, it may not. All right, so now we have a string type, which gives us access to nicer methods. So we're going to say dot split, and this gives us a nice pattern that we can split against, which in our case is going to be r in. Cool. Line splitter. And what's happening here is that this is actually creating a lazy evaluating function. So this itself is not doing the splitting. Instead, it's generating a function that will do the splitting as we call and iterate on it. So one of the things that we're going to be doing is taking just one of the elements of this and then collecting, which should then give us a string as a result. Okay, sweet. All right. So this, assuming all has gone well, we have our initial line. And now what we're going to be doing is splitting on the space character. So let's call this let line parts equal line splitter dot split again. So let's call this a better name. First line, slightly better name. First line dot split again, space character, and we're going to collect all of the potential output of that splitter as a vector of strings. You're not gonna. All right, fine. References. Cool. I think that's fine. We're gonna go with this. And we're gonna delete that as we go. So we have our line parts. I don't like that name, but for the moment, let's go with that. If the length, if line parts dot length is equal to 2, then we are going to return HTTP version 09. Sweet. And we can delete that. Match against the third element. Okay, now we're going to match against. We really should check that it's longer than that. Yeah, you know what? I'm going to do it. I hate it. But let's validate that it's bigger than that. If line parts dot length is greater or say equal to 3, else HTTP version. Oh, here's a fun thing we're about to do. Unsupported. A moment. It'll be like, hey, this doesn't exist. And I'm going to say, go generate it for me. Ah, and it looks like it failed. All right, fine. Nope. All right, the language server has failed. All right, I will add my own. Unsupported. There we go. All right, so we have validated that we have 3 parts, and now we can match against it. So we go match, line parts, and we want our third item with 0 based indexing, so 0, 1. So 0, 1, 2. Want our third item, we're going to match against it. And it's going to say andster, which means that we can do this. So we can do P, and what do those look like once more? / 1.1. And if we do that, then we know we have HTTP version 1.1, comma, right. Oh, cool. That's fine. I don't want to do a reference anyway. Then we can just do const compare to that. That's great. Get rid of that to do. Matter of fact, I can get rid of this return here. Line parts. Oh, here's a nice thing. We're getting a bit longer. Uh, let's go another 3 minutes and then end this video here. All right, so we have our line parts. When we're doing matching, part of the matching in Rust is that you must do exhaustive matching. So what it's complaining about right now is it says we haven't matched exhaustively, and so we must, especially for the type of stir, which is a reference to a string. And it's impossible to match against that since a string could literally be anything. So what we have to do is handle the catch-all case. So this is forcing us to make sure that we write the default case. It won't let us compile. As a matter of fact, let me show you. Let me try to compile. Let's go back to our terminal. New terminal, cargo, run, release. It'll yell saying you haven't covered this pattern, which is cool. I mean, very neat. So let's put this in. So at least it will stop yelling at us. And we're going to go HTTP version unsupported, just like we were doing down below. All right, now let's match against the other ones that we do support. So HTTP 0.9. Next, we were doing HTTP uh, 2. I believe it's just a 2 with no decimals. We're going to have to check that eventually, but not right now. V2. And finally, we're going to do the handling for our HTTP 3 variant. Version v3. Alrighty. Cool. So we have this, and we should be able to check, make an assertion that this return here that we're getting, HTTP version, is equal to 1.1. So HTTP version, compared against our enum, be 1.1. All right, let's open a terminal, run it again. Yep. It doesn't like. Okay, cool. This is actually one of those nice things, by the way, of Rust, that it does range checks. It will not allow us to reach off into memory that is not ours. This is part of its whole memory safety thing, is the input value that I passed in, or the input array that I passed into that function was only a size or a length of 36. But I was trying to take a slice all the way up to 1024, and it said, nah, can't do it. So we need to do this attempt to take, let's see, I think there's a method that allows me to conditionally attempt to take up to it or the max. Shucks, we're gonna have to write our own. That's fine. We can do this. We are tool builders, and we don't mind getting our hands dirty. So, buffer 1024. What we really want to do is we want to take the max of either the buffer length or 1024. Yeah, that's really actually what we're trying to do. So we're going to say that buffer, we're going to call this buffer slice limit, since this is taking a slice of the buffer when we do that, is equal to, and this type is called the usize. Okay, so we're going to cheat here a little bit. I won't fully explain myself. Do 1024. Guess we should do the min. I was about to shoot myself in the foot. Okay. So the other is buffer.length. There we go. All right, so basically if this value is smaller than this, then it will be assigned into here. Otherwise, we will default to 1024. Now we can come and replace this value right there. And c'est bon, tout c'est bon. All's well. All right, this is great. This is enough. It's 30 minutes, and next time we'll start parsing the URI.